Okay, we've already done some work on regressions on how to find them, put them in the calculator, and actually create a scattered plot. And that's what we're going to do today also with the notes. We're starting on page 22 with number 3. You're going to need your note packet in front of you and a graphing calculator. All right, it says the following table provides average cost per no-fault claim in New York State. Create a scattered plot for the given data. Let t equal 0 represent 1990. All right, what we're going to do is we're actually then going to change our years from 1990 to be 0, and that'll be a 1, 2, 3, 4, 5, 6, 7, 8, and 9. So they basically don't want you to put 1990 in. They actually want you to put 0 in for 1990. So this is going to be our L1 list, which is our X values, and this is going to be our L2 list, which are our Y values. We're going to hold off on creating the scattered plot for now. First, we're going to actually go to letter B and C before we actually plot it. All right. Determine the linear and exponential functions that best fit this data. So they want us to determine each. So by doing so, we're going to have to put this information into the calculator. So we're going to go to Stat, number 1 for Edit. You're going to plug in the lists into L1 and L2, and then you're going to go to Stat, arrow to the right to Calc. And the first one they want us to find is the linear, and if I can remember, that's number 4, which is linear regression. All right, pause the video, plug all that in the calculator, and come back. Okay, now that you have that into the calculator, they said that the linear regression, and they want you to round your values to the nearest thousandth. So for the linear, it's y equals ax plus b, according to what the calculator says. So y equals my a value to the nearest thousandth is going to be 335.394 x plus my b value is going to be 3354.127. Now again, I've got my values right off the calculator. All right, they also want us to do an exponential. So now in your calculator, you're going to go Stat. Well, hold on before you do that. Hopefully you didn't do that. If you did, go to Stat, number 1 for Edit, arrow to the right, Calc, and go back to linear regression. I'm looking what letter C says. Letter C says it wants to know which function better fits the data. So I better write down my R value so that I can choose which regression better fits the data. So my R value for the linear is 0.98, and again, I'm getting it off the calculator just like you are. 2115146. All right, now hit Stat, arrow to the right to Calc, but instead of 4 for linear regression, this time we're going to actually choose 0 for the exponential. So let's put that in there, 0 for the exponential regression, and then hit Enter. And then we're going to copy what it says. Okay, so for the exponential, it is y equals ab raised to the x. And again, I need my values to the nearest thousandth. So it's y equals 3489.424 times 1.072 raised to the x. Again, I'm finding my values off the calculator just like you are. All right, I'm going to put that guy's correlation coefficient, which is my R value, down, 0.9885964,003. Because by doing that, looking at both R values for the linear and the exponential, I should be able to answer question C, which is which function better fits the data. Hopefully your answer is exponential, and tell me why. Agree. Because the correlation coefficient, which is your R value, is closer to 1 than the other one is. All right, now I want you to go and create the scatter plot on the grid below. Pause the video, then come back and see if yours matches mine. Well, hopefully yours looks very similar or exactly like mine. I have a break in the line because from 0 I went up to 3,000 for my y-axis, and I counted up by 250. So that I could get to 7,000 without a problem. You might have gone up by 1,000, but if you did go from 0 to a high number, you need to have a break in the line. Everything is labeled and plotted, and there is my scattered plot. All right, we need to go on to the other page of notes. And again, it talks about all the other regressions. Now, I showed you that in class on Friday before we left for Easter vacation, how basically to find the other regressions. Remember, if they're going to talk about a linear regression or a line of best fit, and let's write this down here, line of best fit, you're only going to do the linear. If they talk about curve of best fit, you're basically going to look at the other three here. So these three here would be curve of best fit. And the way that you can decide which one to choose, again, is by looking at their correlation coefficient, which is the R value, determining which one is either closer to 1 if they're all positive or closer to -1 if they're all negative. All right, let's go on to the next portion of the notes. Well, for me, it's the next page. For you, you look below this. So again, it tells you how the A, B, and C values will be provided, and X and Y are always constant. And it says exactly what I just said. If it's line of best fit, you're always doing the linear. If it's curve of best fit, then your choice is exponential, quadratic, power, or log. All right, let's take a look at example number 1 here. Given the scattered plot, which of the following equations would best model the data? Well, looking at it, it's in quadrants 1 and 4. And the only curve that goes through quadrants 1 and 4 is your log curve. If you didn't know that, you would have to go to the graphing calculator y equal and plug each of them in at a time and take a look at the actual curve to see which one looks very similar to that. All right, let's go on to the next page, to our next example. Given the scattered plot below, which of the following equations could best model the data? Well, it looks like a curve, so it's definitely not going to be choice number 4, because 4 is a linear. So I'm going to actually have to go into my calculator to the y equals, plug it in, and see which one actually looks very close to that. So pause the video, do that, and decide which one. Well, hopefully you chose choice number 2, because it is choice number 2. That one looks as close to that picture as possible. All right, given the scattered plots below, determine which type of function, whether linear, exponential, log, or power, would best model the data. Well, the first one is very clear. It looks like it would be a linear, so let's write that down. Which, if you remember, is y equals ax plus b. This one here, it looks like it stays in quadrant 1, but then goes to quadrant 3. So it looks really close to an exponential, but because it dips down, it's definitely going to be a power regression, which is y equals ax raised to the b. All right, and the last two, let me move this over a little bit. The one on the left here looks like it stays in quadrants 1 and 2, so it's definitely an exponential regression, which is y equals ab raised to the x. That's the one we're used to using. This one here is in quadrant 1 only, but if you take a look at it, it looks like it's going to flow and then go to quadrant 4, so it's definitely your log regression, which is y equals a plus b ln of x. All right, so that rounds up what they look like and what they're called. And again, you've been working a little bit with these regressions. So bring your notes to class tomorrow so that you can continue on working on your note packet. Have a good day.